Okay, in this lesson, I'm going to talk about why do I teach the tip to tail method instead of the other method, which is the parallelogram method. Okay, so this particular lesson is simply a very short video on why is tip to tail method more superior than the parallelogram method. Okay, so the main reason which I'm going to show now is going to be explained later, but I'm just going to show you the main reason. The main reason is because the tip to tail method can find resultant force in a situation where there's more than two forces, alright, acting on the body. Parallelogram method, on the other hand, can only find resultant force when there are two forces acting on the body. If you have more than two forces, you cannot use parallelogram method, alright. So that is the main reason behind it. So let us look at first of all a case where there are two forces acting on a body. So if you use parallelogram method, basically you are just completing the diagram into a parallelogram. So you will have the 3 Newton force drawn in the opposite direction with the same length and direction as this force here, and the 5 Newton drawn in the opposite side. So this becomes a parallelogram, and this is your resultant force. So no issue, the parallelogram can solve it easily. So does the tip to tail, but in this case you need to move your 3 Newton force all the way to the other side. So you have a tip to tail, the tip of the 5 Newton to the tail of the 3 Newton, and you have your resultant force. Okay, so in both cases we have no problem solving for the resultant force as well as the direction. So how do you use it when you have more than two forces? Let's say you have three forces. Say we add one additional force that is pointing directly to the right. How are we going to solve it? First, if we use parallelogram method, what happens? Obviously you cannot do anything because you cannot have three sides, okay, which becomes 6 sides in a parallelogram. Parallelogram has only 4 sides, so it can only have a pair of forces which is 2 forces and not more than that. So you cannot solve using this method. But then if you use tip to tail method, how do you do it? So actually the method is very simple. I'm just going to show you the resultant diagram. It's going to be this way, and you can still solve for the resultant force. In this case, the resultant force is slightly more than 7 Newton. It's going to be longer, and it's going to point more gentle. The angle theta is going to be smaller than the angle just now. So what is the difference between the tip to tail of a 2 force and a 3 force diagram? In the 2 force diagram, the second force is redrawn here, where the tip of the first force meets the tail of the second force. So in a case of the third force, same thing, you just redraw it here, where the tip of the second force, the tip of the second force meets the tail of the third force. That means that you are actually tracing like a track, you are tracing a line. The first force 5 Newton, then you carry on with the second force 3 Newton, and then finally a third force 2 Newton. Then the resultant force is still the same, starting from the first point to the last point. Okay, so using the same question, which is these 3 forces, let me show you that actually there are many ways you can draw the 3 forces and using tip to tail and find the resultant force the same with the same answer. Okay, so the first method is of course the 5 Newton first, followed by the 3 Newton, and then followed by the 2 Newton, and then you have the resultant force. But you can shuffle it around and you don't have to start with the 5 Newton. What if I prefer to start with the 3 Newton? Then if I start with 3 Newton, I can carry on with the 2 Newton and then the 5 Newton, and I'll still end up with the same resultant force. Observe that these two diagram has the same direction and magnitude. Alright. Then lastly, I can also start with the 2 Newton, then go to the 5 Newton, and then the 3 Newton, and yet I still get my same resultant force, which has the same direction and magnitude. So one of the things you might observe is this. The diagram may not be a polygon. It may not be a rectangle or polygon as what you have expected. Like in this case, it is a very strange shape. So do not expect to see that the shape is a very nice polygon. It may not be. Alright, it may be something like that, because the forces may go in strange directions. So when you see this kind of answers, right, or you see that you constructed and it become this kind of construction, don't panic, you may be on the right track. Okay, if you want to verify, you can redraw in a with a different force as the starting force, and if you arrive at the same answer, then you're probably in the right track. Okay, so this is just a small explanation on the tip to tail method. I hope that this video explanation will help you. Okay, so that's all. Thank you and have a nice day.